Hi guys, today we are going to apply properties of similar triangles. All right, so let's take a look at this first one. It's called the triangle proportionality theorem. And basically what this says is if you have two lines that are parallel, so if a line is parallel to a side of a triangle, okay, so these two lines are parallel here. We got a line here that intersects and it's parallel to another side of a triangle. Then what it will do is it will divide the two sides. It will actually divide the triangle proportionally into two sides. It's going to divide this side here over this side is going to equal this side over over here, right? So we have AE over EB is equal to AF over FC. All right, let's take a look at how this works. The key thing is looking to see where your parallels are. My parallel lines are here. Okay, so that's where the division is going to occur. So we can put our line, little line here, equal sign in between. So this over this is going to equal that one over that one. So the 6, and this is what we're looking for. We're trying to find EG, so we're going to put an X there. So 6 over X is equal to 5 over 7.5. Okay, once you set it up, you cross multiply. So we get 6 times 7.5 equal to 5 times X. So for that 6 times 5 there, we have, 6 times 7.5, is 45 equal to 5x. Divide by 5, x works out to be 9. So we have x equaling 9 there, and that EG value then is equal to 9 because that is our x. All right, let's look at the next one on the other side. Once again, we're looking for the parallels. You can see the parallels right here. We can make our proportion out of this. So again, the 20 over the 30 is equal to the 11 over the x. Again, follow where that parallel line goes, and that's where your two bar lines go for your each ratio for the proportion. Okay, so I'm going to cross multiply. 20 times x is equal to 11 times 30, so 20x equals 330, and x works out to be 16.5 there. So we know that the length of JG is equal to 16.5. And actually, because it's a length, we don't need that symbol on top. So that is our final answer for that. Okay? Now, the next part, we're going to take us into the converse of this theorem. Okay, so basically, all it says is that if you know that the length of AE over the length of EB, so if you know that this piece over this piece is equal to this over this, right? If we know that's the case, then automatically we will know that that line has to be parallel to that line. You will know that those two lines have to be parallel. That's your conclusion there. So if the line divides two sides of a triangle proportionally, then it is parallel to that third side there. Okay, so let's apply. This is the same exact idea here. We're looking for the length of RQ. So once again, here's our parallel lines. And properties of proportions tell us it really doesn't matter. As long as your dividing line is here, I can do this piece over this piece equals that piece over that piece. So I can set this up as 12 over x is equal to 6 over 7. So it really doesn't matter if I do x over 12 equals 7 over 6, or I do 12 over x equals 6 over 7. It doesn't matter, you just have to be consistent. Okay? Again, the pattern has to be the same. If I do that over that, I have to do that one over that one. If I do this over this, I have to do that one over that one. You just have to be consistent. All right, so we need to find the length of RQ here. All right, so we're going to cross multiply. When we do that, we get 6x equals 84, and that x works out to be 14. So the length of that RQ is equal to 14 there. Okay, so look at the next example, same exact idea there. This time, you know they're parallel, they're telling you, so therefore you automatically know that we can do 20 over 16 equals 38 over, and I'm going to call that x because we have to find jn there. So 20 over 16 equals 38 over x. You could also have done 16 over 20, but if you do 16 over 20, you have to do x over 38. Right? So it could be either way. Either way would work, just like I told you over for that one. So again, we cross multiply. 20 times x, 16 times 36. 20x is equal to 608. We divide, we get 30.4. So the length of that jn value, my x, is 30.4 there. All right, let's look at the bottom example on this side. All right, it says show that they are parallel. Well, in order to show they're parallel, we have to prove Again, what we want to try to find out is, are these lines here parallel to each other? Again, what we have to prove is that 18 over the 45 is equal to 6 over 15. If that works out when we cross multiply, then those lines will be parallel to each other. So I'm going to set this up. 16 over 45 equal to, and that, again, I did this one over this one, so I have to do 6 over 15. Okay, and I can cross multiply there. So I get 18 times 15. Does that equal 45 times 6? I don't know. We're not sure about that just yet. We're not really sure, okay, if it's equal. But when I multiply it, 18 times 15 is 270, and 45 times 6 is also 270. So that works. And again, I could have also set this up as 45 over 18, but if I had done 45 over 18, I got to do 15 over 6. You can see why it doesn't matter, because again, you're still cross multiplying the same things, 18 and 15, 45 and 6, and you will still get 270 equals 270. So because that proportion works out to be equal, we know that TU has to be parallel to WX by the converse, because the converse is the one that says if these are proportional, then those lines will be parallel. So we will know that those lines are now parallel by the converse of the triangle proportionality theorem. Okay, triangle proportionality theorem. All right, let's go to the next page. All right, we got another theorem up here. This one is called the Two Transversal Proportionality. Okay, again, just as easy. It says if three or more lines, parallel lines, so we know in this picture that this, and this are all parallel. Okay, they're all going to be parallel to each other. And if they are parallel, the length from here to here over this one down the bottom is equal to this length here over this one over here. Again, it's that same kind of pattern. You just have to follow that pattern. The length of AC over the length of CE is equal to the length of BD over the length of DF, as you can see right here. Okay, so let's set this up. It's pretty simple to set these up. Okay, first of all, guys, they should tell you that these lines are parallel. They should tell you they're parallel. Now, once that happens and you know these lines are all parallel, all you have to do is set a proportion. This over this equals this over this. That's all you have to do. So we know that 2 over 3 is equal to 5 over x. And then we just cross multiply. 2x equals 15. Divide by 2, and x is equal to 7.5. And that's how you do it. So look at this next one over here. Same idea. Once again, they should have told us these are parallel, okay, to know that we can do this. So we know that A is 4, B is 8, C is 5, and we don't know D. It tells us to find what C plus D is, but we have to find D first. Okay, so I called that X. I called that little piece from here to here, I called that X. So I set it up. 4 over 8, all you do is take this over this. So 4 over 8 is equal to 5 over x, 5 over x. So 4 over 8 equals 5 over x, cross multiply. 4x equals 30, x works out to be 10. Now, that's our D value. They wanted us to find C plus D. So C plus D is going to equal 5 plus 10, which is 15. So there's the length of C plus D. Okay? Last theorem is called the triangle angle bisector theorem. Okay? And again, we're going to be using proportions on this one. Basically, all this says is, okay, if an angle, bisector of a triangle divided the opposite side, that word should be opposite. So here I have an angle bisector. We know because the two angles are equal. They're going to have to tell you it's an angle bisector. So you know it's an angle bisector, the two angles are equal. That right there, that line, that angle bisector is going to divide, okay, it's going to divide these two segment lengths proportional to the lengths of the other two sides. So these are proportional to these. So they have it set up over here as this over this is equal to that over that. And that's fine. You can do it that way. That would work. This over this equals that over that. But I personally find it's easier to simply find the angle bisector, okay, just like I did here, put an equal sign on it, and then put a slash and a slash on the two sides that are next to it. And now what I do is I take the length of AB over the length of BD. So this over this is equal to that over that. So AB over BD is equal to AC over DC. All right, so let's take a look at this one. Here's what I'm saying. Okay, we know we have an angle bisector. Here it is here. My angles are equal. I am going to draw my division line right there, put an equal sign right on that line, and draw my other division sign over here to make myself a little proportion. So I'm going to have x plus 3 over x. So I'm keeping the left side of the triangle together here, and I'm going to keep the right side of the triangle together, equals 10 over 6. Okay, so now I have my problem. X plus 3 over x equals 10 over 6, and I'm going to cross multiply. I have to put that in parentheses so I remember to distribute there. So that's 6 times x plus 3 is equal to 10x. All right, so we've got to solve this. So 6x plus 18 is equal to 10x. All right, I'm going to subtract 6x over here. That leaves me with 4x is equal to 18, and when I divide, I get a decimal. X equals 4.5. Now, what did it ask me to find? It asked me to find LP. Well, LP is x. So the LP is 4.5. It also asked me to find that ML. That ML is x plus 3. So that's going to be 4.5 plus 3, right? So that ML is equal to 4.5 plus 3. So that value is going to be 7.5. So ML is equal to 7.5 and LP is equal to 4.5. Okay? Number 7, I kind of already have set up for you. Same idea. Here's my angle bisector. Put my equal sign on the angle bisector, draw a line, and now I have my proportion. I have x over 8 equaling x plus 2 over 12. And then I just cross multiply, okay? Put parentheses around this so you remember to distribute the 8 times the x plus 2 here, and then x times 12. So we distribute here. 8x plus 16 is equal to 12x. Subtract 8x, I get 4x is equal to 16. Divide, and I get 4. Then I have to plug it back in. EF was x, so that one's just 4. And then FG was x plus 2, so 4 plus 2 is 6. So our FG value there is equal to 6, and the EF is 4. All right, let's do another one. Same idea. Here's the angle bisector down here, okay? So I'm going to draw that line. I need to make sure I see that. That's my angle bisector. Okay, now remember what I told you to do. Equal sign right on there. Draw a line, draw a line. Okay, now I'm going to set it up. And I can do it either way. I can either do x minus 1 over 4 equals x plus 3 over 5, or I can do 4 over x minus 1 equals 5 over x plus 3. It doesn't matter, okay? So 4 over x minus 1 equals 5 over x plus 3. Okay, so I did this over this equals that over that. You just have to be consistent with your patterns, okay? So I'm going to put parentheses around these so I remember to distribute. So 4 times x plus 3 is equal to 5 times x minus 1. Okay, 5 times x minus 1. Okay, so I got to distribute. I'm going to get 4x plus 12 equals 5x minus 5 there. And I'm going to bring the 4x that way and the 5 that way. So subtract 4x on this side, I get x. Add 5 over here. Okay, and I get 17 there, and x would equal 17. Now again, you just have to go back and plug it in. NP is this whole length, so NP is going to be equal to 17 plus 1, which is 18. It's minus 1. Sorry, made a mistake there. 17 minus 1, so that's 16. And I need to plug it in over here too. LP is equal to x plus 3, so 17 plus 3, so I get 20 for that one there. So those are my two answers. NP is 16 and LP is 20. All right, and the last one here, exact same idea. Here is my angle bisector. I put the equal sign right on it. I drew my line here and here, and now I set it up. I did 3y over y plus 3 equals 40 over 16. 3y, y plus 3, 40 over 16. Again, I'm going to put parentheses, anything with a plus or minus, because I have to remember to distribute when I cross multiply. So 3y times 16 equals 40 times y plus 3. Distribute the 40. 40y plus 120 is equal to 40y plus 120. And on this side, I got 48y. So I'm going to subtract the 40y, get 8y left, equals 120. Divide by 8, and I get 15. And then I have to go back and plug it in. So I wanted to find out RV. RV was 3y, so I did 3 times 15 equaled 45. And I also had to find TV, which was 15 plus 3, which is 18. So those are my two answers there. Okay, guys, if you struggled with any part of this, go back and rewatch the lesson. Okay, good luck.